In a previous video, we learned how to find the determinant of a 2x2 and a 3x3 matrix in a quick and simple way. Today, we're going to find the determinant of an n by n matrix by looking at a procedure. Please be sure to subscribe so you don't miss out on any future videos. Now let's look at the process of finding the determinant of an n by n matrix. Step 1, choose any row or column in the matrix. For this example, we're going to choose the first column, and it consists of 3 elements, A, D, and G. Multiply each entry in the selected row or column in the matrix by the determinant of the matrix that remains after deleting all the entries in the same row and column. So let's look at an example. Because we have 3 elements in this column, we need to have 3 terms in our determinant calculation. So first we're going to look at element A. We need to delete all the entries in the same row and column as element A. And now we are left with a matrix. Therefore, the first term is the element A is multiplied by the remaining matrix after deleting all the entries in the same row and column. How do we determine if these contributions are added or subtracted? We use the sign convention chart, where the upper left corner always starts with a positive sign. Since element A is in the upper left corner, we assign a positive sign to this contribution. Next, we look at the second element in this column, which is D. We need to delete all the entries in the same row and column as this element, and we are left with a matrix. And this matrix is multiplied by the element D. And because it is in the second row and first column, we can see that it's a negative, therefore it's subtracted. And now we look at the remaining element, which is element G. We delete all the entries in the same row and column, and we're left with the matrix, 2x2 matrix. And because this element is located in column 1 and row 3, which is a positive, we're going to add this contribution. And this is the formula to determine the determinant for this matrix. Next, we will look at an example. Now we will calculate the determinant of a 4x4 matrix. The first step is to choose any row or column in the matrix. It's best to select a row or column that contains the most zeros. So in this example here, we can see that row 2 consists of 3 zeros, and we will choose this to reduce our computational effort. Next, we're going to perform step 2. So we need to multiply each entry in the selected row or column in the matrix. So we've selected this column this row right here, and we know that it has 3 zeros, and a 0 multiplied by any value is 0. So we only have one element that we need to assess in this row. So we're going to select this element, and we're going to delete all the entries in the same row and column, and we're going to multiply this entry by the remaining matrix. So determinant A is equal to -1 times the remaining matrix. And this value is negative because this element on the sign convention chart is located over here, and this is a negative value, therefore this term will be negative. Next, we are going to call this matrix, this remaining matrix, and we're going to denote it as matrix B. Therefore, in order to calculate the determinant of matrix A, we need to multiply the determinant of matrix B by -1. So let's calculate the determinant of matrix B. The first step is to select the row. We will select row 3, because there's 2 zeros here and only one element, which will reduce the computational effort. Because there's only one element, we're going to analyze this element here. Next, we are going to delete all the entries in the same row and column, and we are left with this remaining matrix. And we are going to multiply this element, so this value of 9, by the remaining matrix. And it's positive because we can see that this element is located here, which is positive in the sign convention chart. Next, we need to determine the determinant of this 2 by 2 matrix. And as we saw in a previous video, we can use the simple formula where we multiply the products. So 0 times 2 is 0, and negative 3 times 6 is negative 13. Pardon me, negative 18. And since this is an upward sloping diagonal, we assign a negative value. Negative and negative is a positive, so 9 times 18 is equal to positive 162. And because determinant A is equal to negative 1 times determinant B, which we calculated as 162, the determinant of this matrix A is equal to negative 162. And that's our final answer. Thank you for watching. Please like, share, and subscribe.